All right, so today we're going to talk about our first exponent rule. We've got about 4, maybe 5 exponent rules that we're going to go through. It's going to be the bulk of this unit. And our first one is the product rule. But before we talk about that specific rule, let's get some basic information down first. Go ahead and write while I'm writing a number or variable with an exponent attached So a number or variable with an exponent attached to it is called a base. And we should already all know this, right? But just to review and make sure that we got our vocab down, if we have 5 to the second power, 2 here is our exponent, which would make 5 our base. Okay, and if we add x to the negative 4, negative 4 is our exponent, and x is our base. What's that? Yeah. All right. Have we ever heard the term like bases before? In terms of exponents, like bases. Does that ring any bells to anyone? No. Doesn't seem like it. Maybe? Okay. That's all right if it doesn't. We're going to learn about it today. Like bases are 2 or more quantities that have the same base but may have different exponents. For example, if we had 3 squared and 3 to the 4th, we can call these 2 quantities like bases. Okay, 3 to the 2nd and 3 to the 4th. They have the same base, but different exponents. And the reason why I said they may have different exponents is because if we had 3 to the 2nd and 3 to the 2nd, if they were the exact same thing, they're still like bases, right? The 3's are the same. So they may have different exponents, they may have the same exponents, but as long as that big number is the same, you've got a like base, or like bases. Okay, if we had 3 squared and 6 to the 4th, those would be unlike bases. They're not the same. And the reason why it's important to understand what like bases are is because for the next maybe 4 or 5 lessons, we're exclusively going to be working with like bases. Okay, all of these rules that we're going to talk about, the product rule today, you need to have like bases in order to do the product rule. So let's find out what exactly is the product rule. Okay, and I'm putting product rule on my left-hand side just so while you guys are reviewing these notes at home, which I'm sure you'll all do, probably not, but it's okay. If you need to review the notes at home, you'll be able to see, oh, here's the rule right there. So, the product rule says if two like bases are multiplied, then the product, or the result of that multiplication, the product is just the same base with their exponents added together. These definitions always sound more complicated than they actually are. So I'll give you a moment to write that down. All right. Everyone got that written down? Give me a thumbs up if you got that written down and you're ready to move on. Okay, I see a lot of thumbs down. I'll give you more time. Before anyone asks, no, these notes aren't that long, so it'll be okay. We should have plenty of time to get our work done in class.
You think we're gonna have homework?
I think you should be able to finish in the time that we have, especially because second period's longer. All right, let's jump right into this first example. We got 3 to the second power times 3 to the fourth power. So, are these two quantities like bases? Give me a thumbs up if you think yes, they are like bases. Give me a thumbs down if you think they are unlike bases. Go ahead and show me, everyone. Thumbs up for yes, thumbs down for no. Great, these are in fact like bases. We've got the same base of 3. It's okay that our exponents are different because our bases are the same. So let's see what we're going to do with this. If two like bases are multiplied, it's exactly what we have. The product is just the same base, okay, the same base, which would be 3, with their exponents added together. So 2 plus 4. Just like that. And I'll go ahead and zoom in. Everyone see that all right? Okay. Super simple. All we're doing is recognizing we have like bases and then adding the exponents. So if you're pretty confident with how you add numbers together, this lesson is going to be a breeze. Okay? 3 to the 2 plus 4 ends up being 3 to the 6th. Yes, sir?
Is that your microphone?
Yes, because we have some students that are going to be out, and I want them to get the lessons too. So I'm recording and I'll be posting everything to Google Classroom. Okay? Not too bad of an example, right? What about example B? Let's do x to the 4th times x to the 6th. Can we have variables that are like bases? Yeah, of course. If you look back to our definition of like bases, it says 2 or more quantities. Not 2 or more numbers, 2 or more quantities. So that could include variables and numbers at the same time. x to the 4th times x to the 6th. We've got a like base of x. So we'll rewrite our like base and then add our exponents together. 4 plus 6 equals what, everybody? 10. That's right. 10. I'll give you a moment to write that down. Think about it for a second. Your notes look great. You guys must have had some teachers last year that really instilled good note-taking in you, I assume, right?
Mr. Smallwood.
Mr. Smallwood? He make you take really detailed notes? He retired.
Why?
He's at the age to retire. I would want to retire if I'm at the age to retire. I got a little bit more time, though.
He didn't say anything about it like during the school year, though.
Yeah, I'm not sure. I talked to him a little bit, but what happened to who? Who?
The science teacher.
Oh, Miss... What did you say, Miss Green?
Miss Reed.
Miss Reed. Oh, I'm not sure.
She's been gone for like...
Oh, she went to another school? Oh, no one tells me much.
I had the worst math teacher.
That's all right. Let's move on to example C. Let's go 10 to the 8th times 10 to the negative 5. Ooh. Switching things up a bit here. So 10 to the 8th times 10 to the negative 5. Do we have like bases, yes or no?
Yes.
Yes, beautiful. So we'll write our same base, and then we'll add our exponents. 8 plus negative 5. And if you remember back to our review from last week, what happens when we see a plus next to a minus like this? What does it become, Noah?
A minus.
A minus, exactly. Thank you, fellas. A plus next to a minus becomes a minus. So we can rewrite this as 10 to the 8 minus 5, which equals 10 to the 3rd. So remember, I said try to not think about adding and subtracting as two different things, but just one concept of combining, right? Because with this, it says that we're going to add our exponents together. That's what the product rule says. But when we have a negative exponent and we add it, it's the same thing as subtracting. Okay? So I don't want you to go, wait, no, I'm just going to add 8 plus 5. Boom, 13. Well, it said to add the numbers together, right? Keep in mind when you have a negative sign, it changes what your sum is going to be. All right? Let's do example D, and then we have one more, and then we're done. Nice and short. Let's do 2 to the 4th times 2 to the 2nd times 2 to the 5th. That's a lot of 2's, but do we have like bases?
Yes.
Yes, all 3 of them are like bases. So our definition, like bases are 2 or more quantities. So we can have 3, we could have 4, we could have 1,000 things we're multiplying. We rewrite our same base, add together all 3 of our exponents on the same base, and we get 4 plus 2 is 6, plus 5 is 11. How are we feeling so far? Thumbs up, down, sideways, where you're at right now. Okay, I see some sideways, but I see a lot of thumbs up. That's great. What's up? Okay. Do you want to head up to the news? Okay, I'll get you a pass. Okay, it's right up here. All right, yes. What's that? Can we do one without like bases? Great question. Great question. That's a really, I wouldn't have even mentioned that, so thank you for that. I got a question. Can we do one without like bases? If we had something like 2 to the 3 times 3 to the 4, yeah, have a good day, Alan. If we had 2 to the 3 times 3 to the 4, your brain might tell you to go, oh, that's going to be 2 times 3 is 6, 3 plus 4 is 7. Boom. Can't do that. If we don't have like bases, there's nothing we can do at all. Except expand this out to 8 and this out to 81. It's either 81 or 64. I think it's 64. And then we can multiply 8 times 64. But if we don't have like bases, there's no shortcut rule that we can use. So that's a great question. If you see it, you won't see a question like this on a test because, like I said, there's nothing we can do. So we're only going to be dealing with like bases. It's a lot easier than you may have been anticipating. Real quick, because I think it's important, let's talk about why this works, and then we'll get to work. Okay? Why does this work? Let's try and expand. And let's use example A again. Let's go back to example A, which was 3 squared times 3 to the 4th. So, if we wanted to expand this out, 3 to the second power would be 3 times 3, right? Everyone with me so far? Cool. 3 squared is just 3 times 3. 3 to the 4th would be 3 times 3 times 3 times 3. Oh, whoops. Times, times, times. Still with me?
Yep.
Cool. What do we have in between this first quantity and this second quantity? What's in between? This little dot. What is that? Multiplication sign, right? So let's bring that down in between. And now let's see what we have expanded out. 3 times 3 times 3 times 3 times 3 times 3. How many 3's do we have in total? So our answer would be 3 to the 6th power. All we have to do is add the exponents together. Is that making sense? Perfect. So we talked about how to do the shortcut. Now, why the shortcut works. Let's go ahead and get to work. If there's not any questions, is there anything I can clear up before we start?
Are we
Awesome.
getting a yellow paper?
You guessed correctly. We sure are.
This one right here?
No, that's under the date Monday. Today is Tuesday, sir.